Hello students, in this lecture we will see the third numerical on mesh analysis. So the problem statement is you have to find out current through 2 ohm resistor and 2 ohm resistor is present over here, and of course we have to use mesh analysis for this one. Okay, so the first step is identification of meshes. So there are 3 meshes, one can easily find out. So I will assume the currents in a clockwise manner. So here I am assuming I1 in clockwise manner, I2 in the second mesh, and in the third mesh I will have I3 over here. So I will apply KVL in each mesh and I will obtain 3 equations. So KVL in mesh 1. Now before applying KVL in mesh 1, you need to assign the sign for the voltages developed across the resistances. So when a current enters, you have to assign positive sign, when it leaves negative. Positive over here and negative over here. So I am writing the leaving sign for the voltages over here. I am starting at this point. So here you will have 10 minus 6 times I1 minus 1 times I1 minus I2. And you have completed the loop, so it is equal to 0. So after solving, you will get 10 minus 6 I1 minus I1 plus I2 is equal to 0. I will write down these terms in nice format. Nice format means the coefficient of I1 I will keep as positive. So that turns out to be 7 times I1 minus 1 time I2. Of course I3 is not there, but I will write down 0 I3 over here so that I will not do any mistake while substituting these coefficients and the constants. And the right hand side is 10. So this is my equation number 1. You can check this thing. Even you can have equation as minus 7 I1 plus 1 I2 plus 0 I3 is equal to minus 10, but this I prefer to be in nice format. Now I will write down KVL in mesh 2. So before applying KVL, you need to assign the sign for the voltages developed across the resistances. So I2 enters positive, negative. Here you will have positive and negative, and here you will have positive and negative. And writing the leading sign for the voltages in KVL. So I will have minus 2 times I2. I started at this point. Minus 3 times 3 ohm is shared between mesh 2 and 3. So minus 3 times I2 minus I3, and minus 1 time I2 minus I1. I have completed the loop, so is equal to 0. So after solving, you will get minus 2 I2 minus 3 I2 plus 3 I3 minus I2 and plus I1 is equal to 0. So I will write down these terms and I will get minus 1 time I1 plus 6 times I2 minus 3 times I3 is equal to 0. This is my nice format. What will be my nice format? The coefficient of I2 I prefer to be positive, and the coefficient of I1 and I3 turns out to be automatically negative because the currents through them are in opposite direction. Next, KVL in mesh 3. So I am writing over here KVL in mesh 3. So before applying KVL, you need to assign the sign for the voltages developed across the resistances. For the voltage source, already the signs has been mentioned. Okay. So I am starting at this point. So one can write minus 10 times I3. Go ahead. Leaving sign minus 20. This sign will appear over here, because we are traveling this loop in a clockwise manner. Minus 3 times I3 minus I2, and I have completed this loop. This is equal to 0. So we will get minus 10 I3 minus 20 minus 3 I3 plus 3 I2, and that turns out to be 0. So I will write down the terms in nice format. I1 is missing, so I will write 0 times I1 minus 3 times I2 plus 13 times I3 is equal to minus 20. You can check this equation, and this is my equation number 3. So I have applied KVL in all the 3 meshes and I have obtained the equation. I will write down these 3 equations in matrix format. So from the first equation I will have 7 minus 1 0. Here I will have I1 I2 I3, and the right hand side is 10. Of course we will use calculator to solve this thing, but I will just write down this equation in matrix format. Then I will have minus 1 6 minus 3, and right hand side is 0. From the third equation, 0 minus 3 plus 13, and the right hand side is minus 20. You can see here, since this network consists of only voltage sources and resistances, this resistance matrix turns out to be a symmetric matrix. Okay, you can even check this thing that this 0 indicates that there is no resistance shared between mesh 1 and mesh 3. So this 0 indicates that no sharing of resistance between mesh 1 and mesh 3. So after solving this thing on calculator, you will get I1 is equal to 1.34 ampere, I2 is equal to minus 0.617 ampere, and I3 is equal to minus 1.681 ampere. You can check this thing. But the problem is not over here, because we have to calculate current through 2 ohm. So current through 2 ohm is nothing but, now 2 ohm is placed exclusively in mesh 2. So there I am writing the current through that one as I2, and of course I2 is moving through 2 ohm towards right. So I will mark this direction. So I will write down the value of I2. So it turns out to minus 0.617 ampere towards right, and finally I will make it as 0.1617 ampere towards left. Okay, so that's all about for numerical 3.